So we'll start a discussion of the lecture, and as I mentioned, it's just introductory and says why and what are the various supervised learning techniques we'll be going through. And maybe in the remaining 1 hour, we can just discuss the various points made in the video, as well as anything of interest that people have seen in unsupervised learning over their meanderings around the web. So with that, I'll post the link in chat momentarily, and for the next 53 minutes until 9 a.m. Pacific, let's all just take the time to watch the introductory video. Any questions before we start off? Okay, I'll post that we are watching the video for the next 52 minutes or so. And let's all do that and reconvene at 9 a.m. Pacific, about 52 minutes from now. Thanks.
Thanks.
Okay, folks, it's 9, so we can get going on the second part of the discussion. So before we get into comments of things of interest, any questions from anyone on the lecture? If not, since it's kind of largely introductory, not too many concept details to worry about in this lecture, I'll just throw it open. Anybody want to comment on any of the things that they found especially interesting, or even share any of the other newly emerging techniques in self-supervised, semi-supervised, unsupervised learning that they've recently encountered?
So, yeah, I have a question.
Go ahead.
Okay. Are GANs considered unsupervised learning? I don't know if, not quite sure.
At least for the purposes of this discussion and in general as well, I think they are. There's, I think, in fact, 2 entire modules of this course that are devoted to generative adversarial networks. And so I would say yes.
Yeah, I probably don't know much about the details of GANs because yeah, I don't. Yeah, okay. You just have to give data, right? You don't have to label it anyway.
Yeah. Yeah.
It just produces.
As I said, in fact, as he shows in the examples, it auto generates the faces and auto imports, because obviously there's some reference images that you provide, but it generates faces from starting from noise largely. And we'll get into that on 2 entire lectures devoted to it, but towards the end of the course, because there are a lot many more techniques that are built up along the way before we get to GANs. But yes, GANs are a part of unsupervised or self-supervised.
They said something about the latent variable. That's how you generate the GAN, right? You start with a latent variable, and so yeah, I guess we'll get into it. But so the unsupervised system will learn all the latent variables, or do you get the latent variable by giving the starter image, or how does? Anyway, we can get in. That's too technical, probably.
Yeah, no, it is relevant. I mean, if you are exposed in any way to autoencoders and variational autoencoders, and by the way, a pitch for some other study group related, there's a deep learning PyTorch course that's taught at NYU that there's a study group going on for that. It's closer to the end than in the beginning, but there are several lectures that that particular course covers that touch on latent variables and how they are used in variational autoencoders and so on, which will give you really good fundamental, I think, before even, because this course tends to, I think, assume that some of the material is something that you are at least familiar with. So if you're not familiar at all, then watching those things will help you along the way. But I think there are, again, there's, if I recall correctly, there's an entire lecture on autoencoders and variation autoencoders, again, as part of this course as well.
Okay, yeah, that sounds good. I'll find that find those videos, because yeah, it seemed like there was unsupervised and there was generative, and there was like a gap there because I didn't know how they were jumping across, because it didn't seem to be how that became unsupervised. I've read the the text ones, the transformers and the BERT papers, but not the GANs ones. So that didn't quite make sense to me. Okay, but yeah, I'll find those videos.
I mean, would GAN, just jumping in on that, so I guess would you kind of think of GANs as being sort of a self-supervised technique? Since, I mean, although it's not like, I mean, kind of like, you're playing these two nets against themselves, right? That's it. So it's, I feel like that's maybe a little less different, or that's a little more different than trying to, do something like BERT or GPT-3, where you're trying to, like, get the thing to learn some unknown like, I guess they're both trying to learn that distribution, but it's the way in which you're doing it, right?
Yeah. Also with GANs, you need a certain amount of label data for training the discriminator. Along with the output of the generator, you actually need to tell the discriminator, give the discriminator examples that these are good or these are bad, so that it figures it out over time.
But you need only
the discriminator. And traditionally, the discriminator just checks if it's real or fake in the traditional GAN.
Right. So you need real data, right?
Yeah, you do need real data, but it doesn't need to be labeled.
Well, okay. I see where you're going with it. Okay.
With conditional GANs, yeah, that's the case. But with, I guess, unconditional GANs, then it's you just need real data and a way of generating fake data. Right. And those are like the labels.
In BERT, right? It's it's simple, right? You take the sentence, you remove the last word or some part of the word, and then you have the system figure out, okay, what is it supposed to be? So that's unsupervised. And then he gave an example of like how you take an image, you rotate it, and then you let the system try to figure out if it was rotated or not, or how much. And so that's like really, really simple unsupervised learning, right? But it seems like GAN has like, it's more complicated than that, right? There's a lot more stuff going on.
Yeah, it's not as, and I think this course takes us there step by step, and also I think as Sujit posted, there's a link to this guest lecture on this other course I was referring to, and that one also kind of takes you through the historical steps of unsupervised learning where they started. And in fact, the current course really does a good job because he just takes technique by technique and kind of goes back to not necessarily the beginning of time, but at least far enough back that you learn the building blocks along the way. It may be simple to begin with, but so there's multiple things like within like autoencoders, and what are the steps that have been taken to get to the current state of the art, and within autoregressive models, what is this steps, and same thing for GANs. I'm assuming he'll start with a very basic, as he said, in 2014, and then take you through the steps to where things are at today. And this field, the thing that I think to me was impressive also is they themselves point out in the lecture that when they taught it in 2019, certain metrics and benchmarks hadn't been exceeded. And then by the time the 2020 rolled around, and I'm sure, we are already in 2021 spring. So, yeah, I haven't looked yet myself at some of the benchmarks, but they are probably exceeded in many ways. So this is where, the field is just rapidly advancing, especially in this domain. And to me, what was impressive was the fact that it mentions, in many cases, it might turn out maybe in a few years, maybe already now, that self-supervised is going to be easier and better over time than even supervised, which opens up all new avenues.
Yeah, he had a small comment at the end. It said self-supervised doesn't work very well in reinforcement learning right now. So it's like an open research question. I don't know if there's any work on that to have self-supervised reinforcement learning. I don't know if that even makes sense, but yeah.
Actually, so I guess maybe follow up.
Oh, sorry.
Oh, sorry. I was saying, so the difference. So what then would, I guess, we say the distinction between the self-supervised and unsupervised? We say self-supervised is a subset of unsupervised, or so as I'm saying,
yeah, actually, there was a discussion or a comment that Jan-Lucan made in this in one of the lectures, not in this course but elsewhere, I think, which somewhat summarizes the commentary. The comment he made was, you know, self-supervised is more precise term, and unsupervised is kind of vague in the sense that you know, that is supervised, and then unsupervised kind of assumes everything that is not supervised. So it's kind of not precisely defined in that sense. So technically, or his comment was, it's much more precise to say self-supervised than it is to say, than it is to use the term unsupervised, because unsupervised would mean anything that is not supervised, and that's very vague. That's as far as he would go. He kind of was hesitant to classify self as a subset of because he didn't like the term unsupervised to begin with.
yeah. Okay. Yes, I always hear self-supervised also in the reinforcement learning content, like the self-play kind of thing, like, you know, AlphaGo and whatnot.
Yeah, and I think there is again a module towards the very end of the class. In fact, it's, I think, the last module, which talks about these techniques and their application and relevance to reinforcement learning. So. Any other questions or comments?
Well, just to like add on the question, like that this course was in 2020 and now in 2021, and well, still supervised pre-trained models portrayed in supervised fashion perform better on image applications as compared to those trained in unsupervised fashion. So also there is like some progress, but actually I'm looking at this recent Dino paper, and you know, still the performance compared to the supervised model is still not as good, but like those are bridging the gap, and also with this approach that BioL and Dino takes, like you don't need contrastive examples for training. That really looks interesting. So I would say there is like a lot of progress, but in vision it's still not like self-supervision is not as good and as important as in language, because like in language this transition to self-supervised pre-training was really like a game changer.
Yeah, the transformers plus BERT and the whole lot of techniques, I think, are much more the standard and state of the art in text processing and not even video, image processing. You're saying has still a ways to go to catch up to the same level of performance with unsupervised as you get with supervised.
So it's not related to this course, but is the is the transformer-based image system better than the CNN-based now, or is it still CNN is based and better than transformer? Because I mean, because unsupervised BERT came out of transformer, right? So
those are competing right now. So there is some progress in CNN-based architectures, and in transformers becoming more popular. But still, I think currently, I'm not 100% sure, but I think currently state of the art is CNN based, but the performance is really close.
okay, but I don't think you can do I mean self-supervised with CNN, right? With image, is it possible? I've forgotten. I did read
sure, why not?
Okay.
Just a framework for training. No, it doesn't depend on the architecture as much, but as this Dynapair paper claims that this self-supervised approach is particularly good when you do it with vision transformers.
Okay.
Yeah, I think you can actually, use the ideas of self-supervision. So if you mask out a piece of the image, right, and you ask it to predict it back, right? So you're not really doing any labeling. You're taking an image, masking something out. That's your input, and the output is the unmasked one, right? Similarly with when you're doing super resolution, right? When you're creating your, labels, your labels are actually your originals, and your inputs are degraded quality images based off the original. And you're asking the network to basically take the degraded quality image and create the original image back. So in that sense, because you're not actually spending much effort to create your label data, you could think of it as self-supervision as well.
And also, I would say that transformers have also been applied on top of CNNs. It's for example, FastAI has a dynamic unit and has a switch and configuration to apply transformers on top of what you're already doing or not. And so it's not, in many cases, they can be used complementary technologies too, and not as necessarily as substitutes.
Yeah, just as you can use like combination of LSTM-based parts with attention-based layers. For language, you can use attention in vision. And there is another concept I just stumbled upon recently, this involution, which is kind of has some similarities to both convolutions and like attention, and it relates to attention in a sense that the weights are computed dynamically, but on other hand, it's it's not the computation is somewhat similar to the convolution, like from the point of view what the operation is done. So I guess you can do different things, and different things might work well.
Yeah, but for super resolution, you have to use self-supervised, right? Oh, you do use self-supervised ones, right?
That's right, yeah.
Because also the
that's, again, sorry, if you actually listen to Jeremy Howard in FastAI, I think a couple of years back, not his latest, but version 2 of the course and part 2, where he gets into GANs and that type of stuff. I'll see whether I can dig up the link and provide that. But the point is, for super resolution of images, he was actually pointing to a bunch of techniques and papers that help you regenerate images. It's not in a self-supervised context that you can generate high-resolution images. There are a bunch of techniques which take you past the bicubic or bilinear interpolation in order to get the quality of the images to improve. So the whole thing about high resolution is, while it's one of the domains that it can be applied in is GANs, the techniques there that you learn for generating high resolution images inherently have nothing connecting them to self-supervised learning. You can do that. You can do that, for example, on top of UNets when you're trying to generate images. So these are just a bunch of techniques, and those techniques are applied in the GANs context to generate high resolution images.
Right, basically to create the label data, right? I mean, you're using kind of self-supervision, right? Automating the process, kind of going backwards.
Yeah.
Well, it is self-supervision. Any process when you don't need manually labeling the data,
Yes,
might be referred to as self-supervision. So you generate labels from the data. The same applies to BERT-like training. So you have text, you mask some parts of the text, and then you reconstruct it. And that is considered as self-supervision. You just create your input and label from the same piece of text, right? And the same applies to super resolution. You take a high resolution image, crapify it, and then reconstruct. So it's very similar to what's going on with BERT, right? From the high level point of view.
Just one side comment, not to derail, I guess, because we were just discussing thoughts from the lecture. One thing he mentioned was the ability to, I guess, capture these different angles, right? Like just it was totally unsupervised, and it was able to actually figure out different angles, different views on objects, right? And I guess just train of thought, just going off of that right there, I was thinking about learning, I guess, how to do, I guess, unsupervised, learn in unsupervised ways, semantically meaningful latent representation. So I guess I'm kind of curious if we're going to be touching on that in the course too, because it's cool to be able to learn these implicit distributions, but being able to actually maybe, learn something that corresponds to happy, learn a dimension that corresponds to happy or sad, or rotating an object 1 degree or another. Just wondering, I guess, any thoughts on how learning semantically meaningful latent representations ties in with the rest of what we're doing here, or if anybody has any experience with that. That's actually one of the big reasons I'm interested in looking at this stuff. So just throwing that out there for any thoughts.
Isn't there already a supervised version of it? Because I do remember it 5 years ago or so. You could change the perspective, but it was all completely supervised. Right. Maybe I'm wrong, but
so I'm not even saying just being able to take an image and do something like, oh, I want to rotate it one direction or another, but actually when they were, I can't remember what it was, and I'd have to go back and look at the slides, but where they were basically traversing the latent space in I guess it was the GAN, right? It was transforming one image smoothly into another. So basically just moving along that manifold and watching one image slowly turn into another image, slowly turn into another image, and just, that's cool. But what seems even cooler is if you could actually determine concepts. It's not even necessarily like human concepts, but meaningful concepts associated with these different dimensions in the space, right? Because it seems like a lot of some of the bigger issues we face generally as a field is this lack of an ability to learn an ontology, right? We're sort of relying on just like learning patterns and compacting these together and in a way that you know captures enough information that maybe we can fake it till we make it. But I don't know, just thinking like, how do you actually learn a machine ontology, right? So it's like, this thing is a cat, this thing is a dog, this is how we move from one to the other, here's how close they are in the space. Like, you know, I don't know, just
there was
what, go ahead, Sujit.
No, you continue. I'll come after you.
There is work and research in that space. For example, one of the papers last week that, and I think it's alluded to in the lecture that Sujit posted a link for, the Ishan Mishra guest lecture. One of the things, for example, is recognizing the perpendicular of any object that you see in the image. So you'll have to kind of figure out the 3D aspects of it in order to figure out the vector that's perpendicular to the surface, for example. Therefore, it's learning, if you will, the network is learning the aspects of a surface and the perpendicularity and that kind of stuff. So I think, to your point, and again, the difficulty or the various aspects of what is meant by semantic, and it gets, I think many of the lectures to follow, as well as some of the other papers, I can post a link to some of them, begin to touch on it, but I don't think there's like a single technique, as you'll hear him say, that says, here is how you can capture it, what you're after, the concept of the cat and the concept of the dog in the spaces. But there are the set of techniques that we learn in this course and related readings would kind of begin to throw tentacles around that problem. And to a very, very rudimentary extent, he kind of hints at that by saying that the BERT model, and there are some papers that analyze this with respect to transformer models and BERTs, and BERT model and more complicated, Roberta, Distilbert, blah, 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 variations on BERT, which begin to tease out what the entire technique is learning at the various levels. And I think there's a hint of it when he says, oh, sentiment begins to emerge because it is learning sentiment by itself. So he calls it the sentiment neuron or whatever in the hidden layer. So, but again, these are all, in my opinion, kind of preliminary, hesitant attempts to get at what you're referring to as, the gist of what learning thereafter.
It's everything is super impressive that we're seeing these days, but I don't know, I guess I still tend to fall into the stochastic parrot camp. Like I'm impressed with how good it looks, but it seems like
I think I was to echo your sentiment. I think I was wincing a little bit when he said, oh, look, the GPT-2 or whatever, quote unquote, understands things when it says, oh, the federal stuff and stealing and that kind of stuff. And I think there's a lot of work that the term understands is doing there.
There is one experiment. This again, this was in the DL PyTorch course. I'm not trying to advertise it or anything, but basically once they learn, so this is using celebrity faces, and once they learn representation, it is possible for them to project the image of a man, for instance, right, into this latent space, and project another image of a woman also in the latent space, and then interpolate between the two. Right, So, and as you go through the latent space, you can, bring back the source image, right? And you will see the, person gradually transitioning from, gender, right? So more ambiguous looking person, and then finally the man turns into a woman, or aging, right? So in that sense, I guess it is possible to isolate, if you are able to interpolate between these 2 points on a latent space, right? Let's say between a young man and an old man, or a man and a woman. So, the path you take in the latent space during the interpolation would kind of point you to again, the sentiment neuron, if you will, right? I'm not sure if something like that has been done on text, but it might be something worthwhile at some point, to try it out.
Yeah, that's really actually, that kind of reminds me of a little bit of some of the work in explainability space, right? Like using I guess, is it the anchors concept? I don't know, remember, but basically saying here's 2 ideal representations, and you're saying here's my stereotypical point for old, yes, my stereotypical point for young, and then anchoring with those 2, and then looking at saying, okay, well, if I go from one to the other, then that is whatever that is kind of my age direction.
Right. So I can see this happening in ontologies, for instance, right? If you have, for instance, in a disease ontology, that's what my universe is. So, a disease and a symptom, right? So if you go from a disease to a symptom, and that is the path, you do notice that, between multiple diseases and multiple symptoms, you would have parallel paths, kind of like the man, woman, king, queen example. But yeah, so that's another.
Yeah. And that could actually be, just playing with that idea, that could be useful, I guess, for some of this debiasing work, right? I guess that calls back like what Bullet Boosie and man is to computer programmer as woman is to homemaker paper. And one of the main issues they run up against in there, at least with language, for example, right? There are certain things that are intrinsically gendered, other things that are not intrinsically gendered, like king, queen, gender is an intrinsic part of that. But then, computer programmer and, homemaker, those 2 should not necessarily be, gendered.
Mm-hmm.
And so I guess if you have an idea about, how you can, anchor what this concept is, and maybe I wonder if there's a way to use that is to kind of nudge the system away from some of these more undesirable correlations.
Absolutely, that makes sense.
So, but also like how BERT is used, right? So you train it, and then you have a model, and then you use some little bit of data to kind of shape it into something useful, right? So, so example, in your case, you would just get unsupervised learning, and then you'd have some model of images, and then you would have a smaller task of getting what you wanted, like a latent variable that represents the perspective through just a handful of examples, right? Rather than millions of examples, maybe just just a few.
Yeah.
Does that make sense?
I mean, I think so. Or we say, yeah. So having robust concepts kind of allows you to do compression, I guess. Is that kind of what you're poking at?
Yeah. So it would be like you would already have the model there, this huge model, and then you would say, okay, I can go out and have a motorized thing that tells me the perspective and of the images on a camera, and then I have that supervised. I can do that easily, but you only need maybe a few thousand, and then you can do the transfer learning and have a really good model out of it, rather than just use 1,000, start from scratch, and then it would barely work, right? Because I think that's how they use BERT quite a bit, right? And they have this model, but then they have a small training sample of text, and then you can specialize it to do certain things much easier than like starting from scratch.
Oh yeah,
aspect.
100%.
That's also transfer learning. It was before self-supervision became popular. I guess it was called transfer learning, right? So yeah.
That's true also. So you could probably just do that with the regular transfer learning also.
With and without with or without transformers, the idea is the same, right? You take a partial, or you take part of a working model, chop the head off, and then retrain the head to suit your purposes. The idea being that it has learned enough about the problem domain, for you to leverage that bit and go forward from there.
And that gets back to the, was it the LeCake that he mentioned at the beginning of the lecture, right? So I see a lot, I guess that's why we're seeing the big boost with the BERT and GPT-3 and all these large language models, is because that unsupervised base just captures so much important information, right? I guess, and that reminded me of a paper. I'm going to try and put this in the chat. I feel like it may have been mentioned on the podcast at some point, but your classifier is secretly an energy-based model, and you should treat it like one. Anybody familiar with that one?
I think I've seen it somewhere. I don't remember if
okay, I'll throw that in the chat here. But that one, that was what really got me super interested here, because so I'm kind of doing some work in AI ethics related stuff, and trustability is a big component for that, and just generally like well-aligned machine learning. And it seems that this unsupervised base, that meat of the LeCake, right? That really does seem to be what's missing, right? Like, so what this paper mentions here, I need to go find it, is basically if you can actually like learn that underlying distribution alongside your discriminator, right? You can basically produce something that's going to be state of the art in both the generative and discriminative domains, or at least that's the goal, right? So I can't help but think in maybe 10 years, when we finally solve some of the problems with learning some of these generative components, that seems like that'll probably be a basic part of any discriminative model. Because you have to have a sense of an idea about what it is you're actually doing, right? Right now we're once again back to fake it till you make it, right?
Actually, which kind of points you to the weak supervision aspect that both Arto and Yuri are pointing out in the chat. So it says like pseudo labels. Arto, you want to talk about this maybe?
To talk about pseudo labels, not much. I just mentioned that actually that is what performs best right now on the ImageNet, and the noisy student was quite loud, and I'm just saying that's another like approach to leveraging unsupervised data, and also quite promising one, I guess. And so go on.
On that one, I think at least for me, the concepts I needed to get familiar with were, and for others' reference, I'll see again, I can post a couple of links, because the weakly supervised is yet another term, and I needed to get familiar to understand it better with this concept of student-teacher networks or knowledge distillation. And that's something which, again, is kind of relevant in this space. So if you're not familiar with the terms knowledge distillation or student-teacher network, I think I would encourage you to just look that up, and I'll post some links to that, which also has a direct bearing on the teacher networks in typically produce this weekly, or produces strong labels, and then kind of the student networks help. And they are smaller, the student networks are typically, and they then are able to do as good a job as the teacher networks, but with much less parameters and stuff. And the whole thing is also applicable to this weekly supervised learning.
Yeah, and actually,
that's just something else.
Latest papers in like self-supervised papers, which I mentioned, this Dino paper and Biol paper. Basically, we have kind of student and teacher there, and the teacher is like a version of student which is updated like with exponentially moving average weights or something like that, with some like periodically updated weights, and a student is online model, so that that would be kind of merging this student teacher approach and self-supervised approach, right? And that is how they can do self-supervised learning without contrastive examples.
Interesting. So student is actually smarter than the teacher. Teacher is outdated. Well, behind the student in this case.
Yeah, at least in the traditional original knowledge distillation type of thing, the student is faster and smaller, but about the same level of whatever objective you're after, say accuracy, as the teacher is. That's kind of, I mean, that's the reason for the term distillation, because you're kind of getting the distilled version of what the teacher knows that's relevant to you as a student. But that's, again, there are a few papers on that. That concept becomes more relevant, I think, in the self-supervised domain, which is why I bring it up.
And this SimClear 2 paper, yeah, if you know, again, one of their latest and most successful self-supervised papers, then also combine both so if I remember it correctly, you like train a model in self-supervised fashion, then fine-tune it on a small data set, right? You have a big unlabeled data set and a small labeled data set. So first the first stage is training in self-supervised fashion. The next stage is fine-tuning a teacher model, the model which will become a teacher in the third stage on this small labeled data set. And then you use this teacher to label their unlabeled data and proceed with this student teacher pseudo labeling approach. So that combines these two techniques together, and yeah, so that's what can work well.
What paper was that?
SimClear 2. This SimClear was it's spelled SimCLR. And if you Google, I don't remember what the name of the paper is exactly. But
yeah, I have the reference. I'll post it too.
Yeah, cool.
Thank you.
The one other comment I would make, at least even beginning to get into the lectures subsequent to introduction, he mentions it here, but I think that's something, again, I'm looking forward to, because it's deeply relevant for GANs, but it seems to be much more relevant in general and broadly is in unsupervised learning, is the lots of little details that seem to matter to get things working. So that's where I think the homework and the reference and the collab notebooks. So, I would encourage people to volunteer to take us through those. If you're familiar with code, learn fast from code, please step up and volunteer to lead us through that, because I think a lot of the details that aren't necessarily mentioned or highlighted, I would say, in the lecture become kind of relevant and get highlighted when we go through the code. He kind of mentions in the second part of the introductory lecture that the details matter, and I think that's probably broadly true in this space, and excruciatingly true when it comes to GANs and getting them. That's why you constantly hear GANs are hard to train, they're fidgety, fiddly, and so on and so forth. But I think that's broadly relevant in this space, I believe, because even in the other guest lecture that a couple of people alluded to, that Sujit posted the reference to, you can hear him say, unless you take some very simple things like just gauging the four-way rotation of images, anything beyond that, to get it to train and to work in any reasonable period of time, unless you know what you're doing, is quite hard. I think hopefully I'm looking forward to, kind of wading through the code and picking up stuff that they do or don't do, which would be relevant.
Speaking of that, let me just quickly. I did volunteer in the spreadsheet to lead the homework and the other session. So I can prepare that.
Yeah, that'd be great.
Sorry, please go ahead. Sorry,
somebody
I
was going to
interrupted
say
someone.
Yeah.
Oh, I was just going to ask. So I only just found out about the study group a few days ago. So I watched most of the introductory Zoom call, but I guess were we going to do, or is anybody, are we going to split up into do any projects? Like, I guess form any small groups to work on that. It's like after post homework. I know the class goes through the different homework sessions and then they go into their project section. So I don't know, is there a plan for doing that, or does anybody have any interest in that, I guess?
Yeah, we hadn't slated time for that, but Jonathan, that's a good suggestion to fork off once the course is over, to potentially form teams from people who are here to, or even during the course, if people want to kind of form small teams, do some development work and present the results. We can extend the course as necessary, and if the teams are wanting to present during as well, I can push out the schedule and accommodate that. We hadn't explicitly discussed that in our first kickoff lecture, but if people are interested in doing that, I would happily accommodate that and provide the time for people who worked on such things to come back and present. And obviously you can post on Slack. There's a Slack group just for this particular study group, and so you can post on it to form groups that would be interested in doing that kind of work.
Okay, yeah, and then yeah, cool. It's this whole group is obviously very self-motivated, since it's not a part of a class course or anything else. So that tells me everyone here is probably the types of people that would really put effort and good work into something like a collaborative project or paper or something. So I thought that might be nifty.
That sounds great, and I guess we could cluster according to general interest. So some people
Right.
are more interested in vision applications, some people are interested in NLP stuff and like that, and I guess we could form a couple of groups if there are interest overlap, and that should work great, I guess.
Because I kind of wonder, invariably.
Go ahead.
So yeah, it seems like invariably when you max out a certain number, I guess it typically falls down to a few people doing most of the work. Which I'm sorry to say, I've not signed up on the spreadsheet yet. Most of that is I'm getting married shortly, and there's a whole lot going on. I will hopefully sign up for some stuff like a little later on down the line. But I'm just wondering about forming tight-knit groups, like for I guess improved accountability on a smaller scale as a part of the overall study group, since we seem to have a fair number of people. So on that note, do we want to maybe throw interests up somewhere and then see if anybody aligns on that?
Yeah, actually, you can use the Slack group. First, congratulations on your upcoming wedding, and I think if you sign up, I would, to teach later, I would use that as motivation for everybody else who is, either already well married or still single, to say if a person who is getting married can volunteer. I think the rest of us can. So encourage everybody working off of that to sign up to teach whatever subject within the course that they're interested in. But to your point, Jonathan, yeah, you can use the Slack channel to, solicit people who are interested in subtopics, as Arto seemed to suggest, and then go from there.
All right, thanks.
In the lecture, he does just one thing was that he does say, like, when you do your projects, just run it by their team, the teaching team, so they can sort of help out, like saying, well, I already know of this, or so I that's the only thing, is like we don't have like an expert who can kind of maybe these experts are helpful or maybe they're not, but I don't know if it's possible to have someone who knows this topic so well and can have a kind of give feedback. But I don't know. That was the thought that came to me, was like, well, in the class you could just go to Peter Beal and say, well, I thought of this, and he would say, yeah, it's a good idea, or oh, well, maybe not so, but or it would take too much work, or look at this paper. But in our case, it might be harder to kind of gauge like what the project, the viability is, right? That's the only thing. I don't know if
one approach could be to take some paper which introduces self-supervised technique, and you apply it to like task of interest for you, and so that could be like quite straightforward and possible to do, especially if the paper includes open sourced code. So that's and also I think many people here, like one problem with one problem which is solved by supervisors at universities is when you don't know what problem to take on, and they like suggest you a direction or a problem. But here I guess many people are working in some area and already have some problems they want to solve. So that kind of solves that problem, right?
Yeah, and I think the other thing I would say is I think Arto has already done it in the NLP space in another context, but even taking some papers and which are of interest, broadly applicable, and kind of doing reproduction of their results and things like that can teach you a lot as well. So that's another approach which, and this is beyond when the course was taught in 2020, so there may have been improvements and or new techniques that have emerged which then can be implemented or duplicated and results analyzed and compared.
So we tried to output from a network or something, and if you were to do the equivalent of softmax, that would mean something along the lines of direct equivalent would be, I'm going to put something there with infinitely many outputs, possible outputs, and
sorry, David, can you go on mute?
Oh, sorry.
I think you.
Yeah.
For a second, I thought Peter was in the chat. But yeah, that sounds like a good plan. I think I know people have formed. I don't know if paper implementation, that could be one thing, or if you have the data, then try to train on it. Or I mean, I guess we don't need the data. We're unsupervised, right? So maybe a scraper or something, and get the build the tools, and or if somebody has the compute, or yeah.
Okay, we're heading close to the end of time. I'll again encourage people to volunteer and sign up. And you know, maybe I'll sign up to kick off the next two just to get things going. But as I mentioned, and just to reiterate what we'll do next time around as well, and it gets into the subject matter right away, is again follow the same approach we did today, which is use the first 1 hour or an hour plus 5 minutes or whatever to listen to the lecture, because it provides us the time in this reserved time slot, if you will, and then get into the discussions. And I'd encourage people to sign up to lead us through that. It doesn't have to be a slide by slide regurgitation of what Peter goes through, as much as, you know, kind of relevant discussion, highlight the key points, and so on. So again, thanks everybody for joining, and we'll meet on Slack, and we'll meet again a week from today, and we'll watch the autoencoding or regressive autoencoders, the first part of the lecture, which is about 1 hour and 15 minutes until they break to get pizza.
So before we end, I just have a quick question on the logistics. Cause I did start on homework 1, because at the end of the first the lecture, he says, well, everything
Right.
I just told
Correct.
you in the first hour is in the homework.
Right, right.
So I started on it.
First, the entire lecture.
So I don't know how we want to, do we want to have some sort of homework, like time or some way so we can kind of hang out and do homework or discuss homework? I don't know if it's
that's
possible.
a good question. What I was thinking, Mohsin, and we'll try this, and then, you know, we'll go from there, is what I was thinking is I provided a slot for homework and then a slot for the collab discussion. And my belief is the collab notebook probably, and in fact, I think he pretty much mentions that the collab notebook is in some ways the solution. I don't know whether it's directly the solution, but it may be the implementation of all the ideas they've discussed, whereas the homework might be a narrower or a broader version of it. So to answer your question directly, what I was thinking is maybe we, and at least again, one other comment before I get into the specific answer to your question is, you know, struggling with something and then you know, having a reference implementation or whatever helps more than just directly looking at the reference implementation, because then you think you understand something. But if you struggle with something first, then you know where you're struggling, and then the solution fits and you remember it better. So with that context, maybe what we can do is much like we do in the lecture portion, we can use the first hour of the homework session to just individually try and work through the portions of the homework, and use the second hour where you can take us maybe with the help of the solutions of how exactly the problem has been solved by them. And the first hour we do try to do it ourselves, which will also give us opportunity when the solutions are discussed to each of us present. Oh, but I was thinking of tackling it this way, and what's right or wrong about that?
Oh, I don't know if we can do it in 1 hour. I was thinking more maybe a sticky thread or something that we can work throughout the week on the problems, because there's a whole bunch of them. And I mean, if you know the answer, you can do it right away, I think, but it might take a while.
Right. Yeah, that's a good idea too. And in fact, to your point, I think I would also, as the course encourages, maybe begin to look at the homework problems even now. Yeah, so feel free to start such a thread on Slack as well, where people can chime in and begin to work on the homework even right now. You're right. 1 hour may not at all be sufficient to tackle all of the problems. So it may just be that we'll have to work through over the next several weeks, and then the 1 hour is just an attempt to put the final touches on it, if you will. Feel free to, modulate it as you think best. The only constraint is we just have those 2 hours that we meet in person.
Okay. Yeah, I'll start a thread on it. And I started the homework, but it seemed like it would require, but I don't have background on this as much as other people. So for others, maybe it's just much faster. But okay, that sounds good. We can flush it out more in the coming weeks.
Yeah. Thanks for doing that. Any comments or questions?
One final question. This is actually the first time I've been on Slack, so I'm very new to this. Do we have something set up where people can just, I saw the intros thing, but on the note about finding groups of people with similar interest or complementary interest, would it be good to set up something for that to form these little mini groups or mini homework groups or?
There aren't, you can use the Slack channel that we have, but then if you need to form subgroups within that, again, the Slack channel that we have is set up by the TWIML group itself. So that you may need to coordinate through some offline mechanisms, if you will. You can use the Slack channel. Sorry?
So could we make threads? Like, so you say, homework. So somebody says, okay, I'm interested in doing homework 1 using an NLP data set or whatever, right? So he puts in this thing, and then people kind of, attach, basically they reply in threads, right? So that whole thing becomes its own thread. And so we can actually work within the same, one.
Yeah, that's a good idea. I mean, we can pin those threads for homework threads to the chat itself. So people who are coming in, they can find those threads, and it's a kind of a meta discussion as well, to understand what has been discussed and how it is being progressed.
Yep, that should be possible. Okay, great. So, feel free to start those group threads and discussions on Slack, and I'll post the chat and the recording later today. Thanks, everyone. See you all next week.